If you are going to find out the determinant of a matrix, you must be aware of, suppose you have a matrix A. A is a matrix and it has the entries like 2, 5, -3, and say 7, like this. And you are going to find out a determinant of a matrix. How to find out the determinant of a matrix? Actually, if to find out the determinant, we represent it by these type of straight type of brackets, which is called the determinant of matrix A. It is represented like this. And then what we are going to do in this, we can also represent like this in the straight brackets: 2, 5, -3, and 7. So we are going to find out the determinant of this matrix. How we are going to solve this? This diagonal of the matrix. First of all, this 7 will be multiplied diagonally with 2. Multiply 7 with 2. You will have to observe this method. 7 multiplied by 2, 7 into 2, and there will be the sign of subtraction in between. -3 will be multiplied to the other side with 5. -3 and 5. -3 and multiply 5. So remember this. This is the negative sign which comes between them according to the formula of the determinant. 7 twos are 14. Minus minus plus 5 threes are 15. 29. So the determinant of this matrix is 29. Okay. Now take another example. For example, you have a matrix. Say B is a matrix, and you have 6, 2, 3, and 4. Suppose these are the uh, entries in the matrix. Now you have to find out the determinant of matrix B. How you are going to find out? 6 multiplied by 2. Okay, 6 into 2. This diagonal, first of all, you will have to take this diagonal and then minus sign, minus 3 multiplied by 4 in this way. Now here you can see 12 minus 12. This is equal to 0. So here you can observe that how to find out the determinant of a matrix. That first of all, you have to multiply from this. This is the formula in which I told you that you will have to remember. In the formula, this negative sign comes in between. Okay, you will have to learn this formula, that there must be a negative sign when you are subtracting the product of both the diagonals. The first diagonal, first of all, you will have to take this diagonal, not this. Okay, this diagonal from 7 to 2 will be taken first, and then minus sign, minus 3 into 5 will be taken afterwards, and there must be a negative sign in between. In the same way, 2 into 6, this, minus 3 into 4. So you must remember this formula, that how to find out to find out the inverse of a matrix. Suppose you have a matrix like in the previous example, I got this matrix A. Okay, I got the determinant of matrix A as 29. Now, how to find out the inverse of a matrix? So the formula for the inverse of a matrix is this: that if you have matrix A, suppose is have the elements like 3, 4, 9, 7. Suppose these are the elements of the matrix A, and we have to find out the inverse of a matrix. First of all, we have to find out the determinant of the matrix. You have to see that what is the result of the determinant of the matrix. 7 into 3, as I told you the method, 7 into 3, 7 threes are 21, minus 9 into 4, 9 fours are 36. You have to subtract this, 36 minus 21 with negative sign. minus 15 is the determinant of the matrix. Now, another thing which is very important, which you have to do, you must be aware of a thing which is called adjoint of A. We have to find out the adjoint of reciprocal. We have to take the reciprocal of the determinant like this, multiply. Uh, the formula is this, that inverse of matrix A is equal to 1 over determinant of A. So here we have found out the determinant of reciprocal of the determinant of the matrix A. Now this determinant of the matrix A will be multiplied with the adjoint of A. What is this adjoint of A? Now let me tell you that what is this adjoint of A. For example, in the previous case, if I am taking the example of the this, if I have to find out adjoint of matrix A, how I am going to find out? To find out the adjoint of A, what you are going to do, please observe it very carefully, that how we are going to find out the adjoint of matrix A. If I am taking this matrix, for example, then what you are going to do? You are changing the places of these two elements. You are changing the places of these two elements. Instead of 2, I'll write 7 here, and instead of 7, I'll write 2 here. This is the first step to find out the adjoint. In the second step, you will have to change the sign of this diagonal. You will have to change the signs of this diagonal. This is positive 5, we will write down minus 5. This is negative 3, we'll write plus 3. So in this way, we can find out the adjoint of A. Here I told you that if the matrix A is like this, then what will be its adjoint? We have to change the places of these two elements diagonally. In place of 2, we will write down 7, and in place of 7, we will write down 2. And in the same way, for the other diagonal, we will have to change the signs of these two elements. The negative, uh, this is the negative 5. Previously, it was positive. It is negative 3. It will become positive 3. So this is the method that how you are going to find out the adjoint of A. Now come to our example in which we are going to find out the inverse. So here, for this matrix, what will be the adjoint of A? So as I told you, adjoint of matrix A, again the same method. Please observe, you have to change the places of these two, 7 and 3. Here previously it was 3. Now you will have to write down 7. And these 9 and 4, their signs will be changed, minus 4 and minus 9. So this we have calculated the adjoint of A. Now, this is the formula for finding out the inverse of a matrix. To find out the inverse of the matrix, 1 over determinant of A. Determinant of A is minus 15. Okay. And the adjoint of A, we have already calculated, 7, minus 4, minus 9, and 3. You can leave the answer as it is to find out the inverse, or you can multiply this 1 over minus 15 within the bracket like this. You can also multiply within the bracket. When you are multiplying minus 1 over 15 with 7, it will become minus 7 over 15. And this minus 9, minus will become plus 9 over 15. In the same way, this will become 4 over 15. And this, when minus 1 over 15 multiplied by 3, it will become minus 1 over 5, because 3 5s are 15. This 3 is dividing this 5, because this is numerator and this is a denominator. Please observe this. These are the numerators of these. And here 3 1s are 3 and 3 5s are 15. So this is the answer of inverse of a matrix. Another very important case, when the inverse does not exist. When inverse does not exist. Suppose this Q is the matrix which has the entries like 4, 5, 2, and 10. So first of all, you are going to find out its determinant. Determinant of Q is equal to determinant of Q. 5 fours are 20 minus 2 tens are 20. Result is 0. Here you can see that the determinant of the matrix is equal to 0. Now here, whenever the determinant of the matrix is 0, then its inverse does not exist. Remember this. Its inverse does not exist. Here in the first case, you can see that the inverse, I got the inverse of the matrix, A inverse. A inverse is this matrix, or we can also mention that A inverse is this. Here you can see that I got the determinant minus 15, so I solved it. But if the determinant is equal to 0, then its inverse does not exist. Remember this. I'm repeating again. When a matrix does not possess an inverse, it its determinant is 0. Inverse does not exist. Inverse does not exist because and it is called a singular matrix. Remember this. The wording singular, singular, singular matrix. The matrix whose inverse does not exist is called a singular matrix. Now I'll tell you the reason that why the inverse does not exist. Okay, you will have to see that if the determinant comes 0, then you can straightforward write that inverse does not exist because it is a singular matrix. So now I'm going to explain you that it is a singular matrix. So wherever you see that it is going to simplify, you can write 3 over 5. Here you can see in these three cases, in these two cases, could not be simplified. So I wrote as it is. Here 3 over 15, 3 ones are 3, 3 fives are 15, it is minus 1 over 5. Now I'm going to tell you the reason that why a matrix is a singular matrix. Okay, why a matrix is a singular matrix and why the inverses does not exist. You can see that I told you the formula for inverse. Inverse is 1 over determinant of Q into adjoint of Q. So when I am writing 1 over determinant of Q, here the determinant of Q is 0. Okay, so if I am writing 1 over 0, and whether I am writing the adjoint, whatever the adjoint may be, so what is happening basically? You can see that 1 over 0 cannot be solved. It is an indeterminate form. Whenever 1 over 0 comes, we cannot solve. That is why the inverse of the matrix does not exist. Okay, so remember this very important point, that why inverse does not exist, and when the inverse does not exist, the matrix is called a singular matrix. This must be. Now the exercise 5D, question number 1. In this question number 1, you have to find out the determinant, find the determinants, and B part is the inverse of the given matrix where possible. Why he is writing that where possible? Because he know that when the determinant will be 0, the no inverse will be existing. So from this question number 1, you can see that I can solve a part like part number 4. I am solving the fourth part. In this fourth part, the matrix is written like, please observe this, how I am going to solve this. 2 and 7. Now, if I'm going to find out the determinant, then what I have to do, I have to write this matrix in the straight line brackets like this. This is showing that we are going to find out the determinant. So how it is? 7 threes are 21 minus 2 tens are 20. So determinant of this matrix is 1. Okay, so he is saying that we have to find out the inverse of the given matrix where possible. Now the inverse of matrix, how, because he has not given any name to these matrix A, B, C, etc. So how I am going to write down the inverse of this matrix? So I am directly doing step, the inverse of the matrix is equal to 1 over 1 over 1, because here the determinant of this matrix is 1, and here I am going to write down the adjoint, which I told you that you have to change the places of these two elements. Instead of 3, I am writing 7, instead of 7, and I am writing 3. And I told you that here you have to change the signs. This will become minus 10 and this will become minus 2. Okay, so 1 over 1 gives you 1, so there is no need to mention this. So 1 multiplied by anything within the bracket, the result will remain the same. So the inverse of this matrix is equal to this. In this way, you are going to find out the inverse of the. Listen to me very carefully, that if a matrix is multiplied, if there is a matrix A, when it is multiplied with its inverse, the result will be an identity matrix. Remember this. If a matrix is multiplied with its inverse, the result will be identity matrix. And I told you that what is an identity matrix of order 2 into 2? 1 0 0 1. This I told you last time, that this is an identity matrix. Now here in question number 2, actually he is giving you the proof of this rule. He just wants to you that you must see that how this is coming. A, the matrix A, he is giving, say that 2, 3, 5, and 8. Okay. In the same way, the matrix B is given. You can open the books and you will have to find out the product, and you will have to tell me that what is the result of this A and B. These are the two matrices A and B. You will have to find out A into B. Please solve this. All of you, please look at this question carefully. Those who have the books, please multiply A into B, and then you will have to multiply B into A. First of all, find out this product, and then you will have to find out B into A. It means first you will have to keep the matrix B like this, and then you will have to keep the matrix A. You will have to multiply, and then you will have to tell me the result of these. Okay, you can see that if you will multiply A into B, you will find out the result 1 0 0 1, which is equal to identity matrix. In the same way, if you are multiplying B into A, you will get the same result 1 0 0 1. Okay, this is also again identity matrix. So remember this, A into A inverse or A inverse into A, both will give you identity matrix. So from here we got that if a matrix is multiplied with this inverse in either A into inverse of A or A inverse into A, you will get an identity matrix. Now from here we concluded that A and B are inverse of each other. Okay, A and B are inverse of each other. If you want that this multiplication must be done, then I am going to do this multiplication for the sake of convenience for those who are still unable to do the multiplication. So you can see that here, if I am multiplying this, 8 twos are 16. Look at this multiplication carefully, those who have forgotten the multiplication. 8 twos are 16, 5 threes are 15, 8 fives are 40, 5 eights are 40. The second column, minus 3 and 2, minus 6, 3 twos are 6, and minus 3 and 5, minus 30, and minus 15, sorry, minus 15, minus 3 into 5, and 8 twos are 16, plus 16. So here you'll find that this is the multiplication A into B. 16 minus 15, 1, 0, 0, and 1. This is an identity matrix. Now you can observe B into A also. Let us find out B into A. B into A, 2 into 8, 16, minus 5 threes are 15, 5 twos are 10, minus 10, 5 twos are 10, plus 10, and 3 eights are 24, minus 8 threes are 24, 3 fives are 15, and 8 twos are 16. Here you can see that again it is, sorry, 8 twos are 16. I wrote 18. 8 twos are 16. 1, 0, 0, and this is 1. So again, this is an identity matrix. From here, we concluded then A and B are inverse of each other. We can say the inverse of A is B, or we can say that inverse of B is A. Okay, they have the relationship that they are inverse of each other.